Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others who want to test their math skills with these types of test questions. So this will be our 23rd part in this skills test series. And what we have to do here is that we have to find the area of the green Christmas tree. So we are told a lot of information, so let's go through it here. So we are told that the tree is perfectly symmetrical down the center. So it'd be from point A all the way down to this line or this bottom portion from K to L. We are also told a lot of distance points here, which we are told point A is along the center line at the top. Point C is 12 inches off the center line. Point G is 18 inches off the center line. Point C is 24 inches vertically down below point A. G is 35 inches vertically down below point C. Point B is 42 inches away from point A in a straight line. Point F is 38 inches away from point B. And then K is 59 inches away from point F. So it also says that K is also 50 inches vertically below point G, and it says B, C, D, and E are at the same level. F, G, H, and J are at the same level, and K and L are at the same elevation. We also have some curved portions here, and it says the curve of the tree from point B to point A and from E to A is bound by the equation of y equals theta x squared. The curve from the tree from F to C and on the opposite side as well is bound by y equals alpha x cubed. And then this bottom one from K to G is bound by y equals delta x to the fourth. So we're going to have to use all that information to find how much green area we have in this Christmas tree. So first things first, let's take all this information, especially the coordinate system points or the distance points, and let's make a coordinate system out of it to track everything. So we only have to do half the tree since it is completely symmetrical about point A. So what I did was I split the tree right down the middle, and then I'm going to call this bottom point point O. Now, the procedure that I'm going to use is not necessarily the only one that can be used. It's not necessarily the fastest, the slowest, longest, or anything like that. It is just one possible procedure that you could use in order to solve this problem. So I am going to set up my coordinate system such that K is my origin point for my coordinate system because it is the furthest bottom left-hand point. And now I'm going to throw on a bunch of dimensions and information that was given in the problem statement. So A to C is 24 inches. C to G is 36 inches. G down here to the bottom is 50 inches. And then we also know straight line distances from these curved portions. So B to A was 42 inches. B to F, and of course it's supposed to be a straight line measurement, is 38 inches. That's not vertical, that's a diagonal measurement. And then from F to K, we were told is 59 inches. We are also told that C to this center line here is 12 inches. 12 inches, there we go. And then from G to the center line is 18 inches. Alrighty, so what we're going to have to find is we are going to have to find some distances such as K to over to point G, and then from F to where this point G is, and then from B over to C and whatnot, and so on and so on. So let's start finding out these horizontal distances here so that we can get a better mapping of what's going on. So what we're going to have to do is that we are just going to use these diagonal dimensions, and then we're just going to turn these into little right triangles here. So on and so forth with this as well, and then with B to A as well. And we are going to get these horizontal dimensions like this. So let's start with our first one, which we're going to have point K up to point F. And then directly below point F will be this measurement. So we know that this is 50 inches vertical. This diagonal is 59 inches. So we are looking for this distance from K to a point directly below F. So using the Pythagorean theorem here, X would just be the square root of 59 squared, subtracting off 50 squared. And this gives me 3 square roots of 109, but I'm going to use a rounding here for all my dimensions because it's going to be so much nicer if we just round it. Of course, the engineering way, round it off. So we would have 3 square roots of 109 is 31.22 inches. Alrighty, let's get another dimension here. We're going to get two more here from just using the Pythagorean theorem. So the next one, for the next right triangle, this one will be made up of points F and then B. That's supposed to be a B. We know that the vertical distance here between these two is 36 inches. The straight line distance is 38. And we're looking for the right triangle directly below B here. So we're looking for this distance from F to the point directly below B. And let's just call that Y. So Y, same procedure again. We're going to use the Pythagorean theorem because we made a right triangle. We have 38 inches squared, subtracting off 36 inches squared. And then we get 2 square roots of 37. And this would be equal to 12.166 inches. Alrighty. So let's do one more and let's get the horizontal dimension from this triangle that is forming from A, B, and then this point right here next to C. So let's do this one more time. Or another right triangle. So this would be B. This would be A. Vertical distance between these is 24 inches. The straight line distance is 42, not 38. And then we need that horizontal dimension there, which I'm just going to call Z. So once again, repeat the Pythagorean theorem. We would have 42 inches squared, subtracting off 24 inches squared. And this gives me the square root of 1,188, which is equal to 34.47 inches. All right, so what I'm going to do is I'm going to take these dimensions, I'm going to throw them on here, and I'm going to find my remaining dimensions just by using my coordinate system. So let's go ahead and let's find some remaining dimensions here. Or let's just go ahead and throw everything on once again. So this is 24. This was 36. I'm not going to put the inch tick marks on everything. It's going to get a little crowded here. We'll just know that all these units are in inches. This was 18. This was 12. And we know that this dimension from F to B, this was 12.166. And we know that this dimension over to directly below F from K is 31.32. And we can find some other dimensions just by using our vertical dimensions and our overall dimensions right here. So for B to C, it will simply just be that total that we have from our previous triangle, which we found to be 34.47 inches. So it would just be that 34.47 inches, subtracting off the 12 inches, which gives us 22.467 inches. So this dimension from here to here would be that 22.467 inches. Now with this from B all the way over to here, we can get this dimension from F to G. So F to G would just be 12.166 plus that difference of 34.47, subtracting off the 18. And this would give me 28.636 inches from F to G. So from here over to F would be 28.636 inches. And then we can fill in the bottom here just by using the same kind of process because we have from F to G and then G to the center line. Well, this dimension from 34 or 31.32 is from K to the point directly below F. So we can get this total horizontal here, which would be 77.956 inches. Or we can go ahead and we can get the remaining points right here as well if we want to, with this being the 12.166 and this being the 34.47. All right, so now we have all our dimensions here. And why did we do that? Well, because we're going to have to break this up into separate areas in order to find the total area here. So the way we are going to break this tree up is, let me see, where did I put it? Oh, I guess I did not save it. Okay, well, the way we're going to break this up, I'll just do it on this one. Thought I had another picture saved on there, but I guess I didn't. What I'm going to do is I am going to split. Let's find something that actually looks a little bit better here. So I'm going to split into multiple areas here. So I'm going to call this first one number 1, and then I'm going to make a vertical line straight down from C, and then a horizontal line from FG on over. I'm going to make this shape number 4, and you'll see why I did that as number 4. This curved portion of F, C, and G, I'm going to make this number 2. Once again, I'm going to go a straight line down here from point G down to this bottom line. I'm going to make this area number 3. There's the 4, and then I have a big old rectangle here at number 5. So I have 3 parts that are involving a curve and then 2 simple rectangles. Well, the 3 that are involving the curve shape 1, 2, and 3, I'm going to have to integrate. Well, what am I going to do with that integration? Well, I am told about boundaries of lines here for each portion. So I have this one for B to A, this one from F to C, and this one from K to G. So what we're going to have to do is we're going to have to integrate these to get their area, but first we have to determine what the variable is for each one of these, the theta, alpha, and delta. Well, how are we going to do that? Well, what we're going to have to do is use these coordinate systems that we have, because remember I set up an X and a Y down here at K, and we're going to use these dimensions in order to get those variables of theta, alpha, and delta. All right, so let's go ahead and let's start working on that. So for shape 1, we have y is equal to theta x squared. So what I'm going to do is I'm going to set point B as a new coordinate system for that individual shape. So I'm going to set x equal to 0 up there, and then y equal to 0 right here at point B, and I'm only going to concern myself with that shape number 1. So what this means is at point A, because of my coordinate system here, my x would be equal to 34.47, and my y would be equal to 24 from this dimension right here and this one right there. Well, this means that when I plug in x for this equation here of x squared, theta is such that it pops out y equals 24. Well, let's find out what k is then. Let's find out, or not k, sorry, theta. Let's find out what theta is. So theta would be 24 is equal to theta times 34.47 squared. All right, well, that means that theta will be 24 divided by 34.47 squared, which gives you an extremely small number here of 0.0202. And of course, there's more decimals there. So instead of going through and running through with these small numbers, what I'm going to do instead is that I am going to set an A value equal to my X in this case, which would be 34.47. And I'm going to set a B value equal to my Y, which is 24. So what I'm going to do then is substitute A and B in here for theta, which means that I would have B over A squared. So my y equation, the original y equation, would just be b over a squared times x squared. And the reason why I'm doing this is because a pattern will form with these integration processes here for these areas. And you're going to see this, hopefully see this pattern show up. All right. So what I have is this equation of y equals b over a squared, x squared. So to find the area, I'm just going to integrate this y equation with respect to x, and it's going to be from my x is equal to 0 to the maximum x that I have. Well, I've set x max as a, and it's going to be b a squared x squared dx. Pretty easy integration here. This just becomes b over a squared times 1/3 x cubed from 0 to a. Well, this is just b over a squared times a cubed over 3. And this would just be b times a over 3 then. And then I can take my 24 and plug it in for b. And then I can take my 34.47 and plug it in for a. and that would give me the area here for shape number 1. So for shape number 1, my area would just be 24 times 34.47 all over 3, which gives me 275.76 inches squared for my area. Alrighty, so there's one area down, and then we're just going to repeat that process for the second shape from F to C, and then for my third one from K to G. Just keep in mind that the equations are going to be a little bit different, but it's going to be the overall same process, and there is a pattern that will form. Alrighty, so for my shape number 2, I am told that I am bounded by equation alpha times x cubed. Well, the same thing is going to persist again. Let's set point F, which is my starting point for that second curve. We'll set that as x equals 0, y equals 0. And then the same thing again, we will set C equal to my new coordinate system here, which is 36 vertical for the y. And then it's going to be 34.636 from F to this point G, which is directly below C. So for point C, we would have x equals 34.636, and then y is equal to 36 inches. Well, as with the same equation as before with the shape number 1, if you were to actually plug in 34.636 and 36 over here, you're not going to get a nice numbers picking out here with this y equation. So let's keep everything in variable form again, and let's set this to point A, and let's set this to point B. But we still have to find out what alpha is in those terms. So we're going to have B is equal to alpha, times A cubed. So alpha is just going to be B over A cubed. So then my y equation becomes this. It's just B over A cubed, x cubed. Look kind of familiar to the previous one? It should be. Should be very similar, because look at the previous one. If we scroll down here just a little bit, we had this. Y equals B over A squared, x squared. Now I have y equals B over A cubed, x cubed. So there's a little bit of a pattern forming here. So just like before, we are going to find the area for our second curve of just integrating this y equation, and we're going to integrate from 0 to A in the x direction, because we have x in terms of A here for the distance. And it'll just be B over A cubed times x cubed dx. Once again, pretty simplistic integration process here. This is just B over A cubed multiplied by x to the 4th over 4 from 0 to A. So this would just be B over A cubed times A to the 4th over 4. Well, this is just A times B over 4. Well, let's just go ahead and let's plug in our A and our B that we have up here of 34.636 and then 36. So the area for shape number 2 would just be 34.636 multiplied by 36 all over 4. And that gives me a total area for shape number 2 of 311.724 inches squared. Alrighty, so now we just have one more to go, but keep in mind, as I said, a pattern will be forming. Look at that one, that's AB to the 4th. Well, looking at our first one, we had AB to the 3rd. Well, wondering what the next one's going to be. So we're going to be looking at the shape number 3 area from K up here to G, and we're going to do the same process again, where we set our Y as 50, and we're going to set our horizontal as dimension from K to the point below G. So let's go ahead and work on that one, and that will be our last difficult one to do. So shape number 3. Once again, I am going to set point K as x equals 0, y equals 0, just to isolate this curve and this area out. So that means that point G, my x would be that horizontal dimension of 59.956 inches, and y would be 50 inches. And this 59.956 just comes from adding these together to get over to here. Alrighty, Well, we are told once again that we have a simple y equation of y delta x to the power of 4 for that curve. Well, we're going to set this equal to my A, this equal to my B, and we're going to find out what delta is. And you're probably wondering or probably already guessing what it needs to be because it is a pattern that is repeating. So we would have B equals delta A to the fourth. Thus, delta is just B over A to the power of 4. So my y equation would just be B A to the fourth times x to the fourth. So let's find the area under this curve. This would just be equal to the integration of the y with respect to x. That is from 0 to a. And it would be b over a to the fourth, x to the fourth dx. Once again, very simplistic integration here. So we would just have b over a to the fourth times x to the fifth over 5 from 0 to a. And this will just pop out to be b a to the fourth times a to the fifth over 5. And let me scroll down here real quick. So the area would just be b a over 5. And then let's plug in our 59.956 and our 50 here for b and a. And we would end up with 50 times 59.956 inches all over 5, which gives me a total area of 599.56 inches squared. Alrighty, so now I have my curve, the area under each of my curves solved here. Well, I have two more shapes to do because I have 5 in total. Well, the next two are just two little rectangles here, and I already have those dimensions. So 4 would just be 12 times 36, and then 5 would be 18 times 50. So for area of number 4, oh, that's not how you spell area. Area of number 4 would just be 36 inches times 12 inches, which gives us 432 inches squared. And then the area of shape number 5 would just be 50 inches times 18 inches, which gives us exactly 900 inches squared. So what I've done is I found the areas. Oh, no, don't delete that page. So what I've done is I found the areas for each of these little shapes. I'm going to add them together, and then I'm going to multiply them by 2 because remember, we split this thing right down the middle, and we have to find out the area for the full tree. So let's add all our areas together, which shape number 1 is on page number 2. A lot of pages here. So this would be my first one, which is 275.76. I'm going to add that with my second one of 311.724, and then add that with my remaining 3 of 599.56, 432, and 900. So, and now we'll multiply that by 2. So total area, which we probably should do this in green, shouldn't we? Total area of green tree will be equal to 2 times all these areas added together, which is 275.76 plus the 311.724 plus the 599.56 plus the 432, and then finally plus the 900. So all of those added together, then multiplied by 2, we get 5,038.09 inches squared as the total area of that Christmas tree in green, or the green Christmas tree. So the overall processes there are not terrible once you set up a coordinate system and you find your missing dimensions, and then you just have to integrate each little portion after you break up your Christmas tree into separate parts. And as I mentioned earlier, this was just one possible way that you could have done this problem. There are other steps that you could do, different ways that you could work the procedure, but this was just one possible path. So I think it's much easier when you set up a coordinate system and you get all your dimensions, and then you can break your shape up and then find each individual little piece and then add them all together. So that's how you would solve that problem. So I hope you enjoyed the video, and I hope you learned a new math skill along the way. And if you want to test your abilities even further, please check out the other videos on our channel. As I said earlier, this is the 23rd part in this series, so we do have a lot more, and we do have other topics on this channel as well. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us out greatly over here. Thank you for watching, and I hope you have a fantastic day.